Hi, Thiago Alves here. On the previous videos, we talked a little bit about connectivity on OpenPLC. One of the key points of any industrial setting is the possibility to see in real time what the system is doing. Usually, we do this through an HMI, or human-machine interface. Those displays often communicate with PLCs and other devices using SCADA protocols. We expand a little further on the Modbus protocol, and today we're going to see how to use an HMI software, a free and open source one, to communicate with OpenPLC, and how to build our own HMI and see the status of our system in real time. I hope you enjoy this kind of content, and if you like, please consider subscribing to the channel and liking it. Also, I would like to thank our sponsors, our OpenPLC Friends. Without them, this video wouldn't be possible. If you enjoyed this content, please consider joining our Patreon website and becoming a sponsor yourself. Okay, so let's see how we can connect OpenPLC software to an HMI. And for that, let me just open up my OpenPLC editor here. We'll be using the same program we used on our last video on PyModbus, right? So just a quick recap. This is a simple PLC program that counts up, right? So it has a main counter here in the center, and I have a couple controls about this counter. I can enable or disable this count, right? I can reset the counter, and I can define the maximum value it's going to count up to. I can also read the current count value on this variable, right? So it's very simple. It has a pulse generator here that generates a square wave here at this pulse coil, and every time the pulse goes up, I count 1 more to my internal count, right? And then when it reaches to the maximum value, it self-resets here through the counter Q. Now, we need a device programmed with this software. I already have my ESP8266 programmed with this counter software from the last video. So now I just need to download and install an HMI software to communicate with my little device. Just to make sure that it is online, I'll just launch up my good old friend, the Radzio Modbus Master Simulator, trying to read a couple values from my ESP. I need to go to connection settings here to make sure that I have Modbus TCP selected and the right IP address for my board. That's correct. My ESP8266 is sitting at the 192 IP address. Okay, so now I'll just create a new data sheet and select holding registers. So I'm just reading the holding registers for that PLC and connection connect. And there you go. It's all zeros besides the first register here that is 10. If we check our program, that's exactly what we should expect. You see the first position, the first holding register is at QW0, so that's holding 10. That's the initial value for my QW0, okay? And I can even play with this if I go to coils and I start my counter here, right? This is my counter enable. I can go back to holding registers, and truly I see that my counting is going up here, up to 10, and then self-resets. So everything is working as expected. Let me reset my counter here and go back to the initial state, right? So I can confirm that my device is working with Radzio. Now let's make it more professional. Let's connect it to an HMI. Well, there are a couple HMI options we can pick from, both paid and free, but I'm a great supporter of open source software, so let's go to the open source alternatives. One of my favorite HMIs is called ScadaBR. And you can find more about it on Google, but just typing ScadaBR GitHub will take you to their GitHub page where you can download and install their latest version. There are some other good options as well. Fuxa is another alternative, but it's still in development and there are some features lacking on that software, and it's also a little bit more complicated to work with. I love ScadaBR because it's simple to use and has all the basic features that you would expect on any SCADA software. But in reality, OpenPLC will talk to any SCADA solution, any HMI that can talk through Modbus TCP. So ScadaBR, because it's Brazilian software, it's originally in Portuguese. I fortunately can read Portuguese, but if you can't, your browser might just show up this translate button that allows you to automatically translate the information here. Straight on the front page of their GitHub README file, you can find here that you can download the latest version by clicking on this link. Right, it directs you to the releases tag with the latest version. That's 1.2 at the moment. And scrolling down, you will see a couple files here that you can download. For Linux hosts, you can just download a zip file, and they have an installer inside that will just install ScadaBR for you. Since we are on Windows and I'm going to install ScadaBR here, I'll just download the Windows version. Now there's one more thing that I need to download as well. ScadaBR depends on Java. For Linux, most distributions come with Java built in. That's not the case for Windows. I need to download and install Java, and it requires Java 8, right? So let's just open up another Google window here, and I'll just search for JRE, which is Java 8 download, and one of the first options here, it's just from the java.com website, right? I click on that, and it will direct me to the latest Windows version for Java. And I can just click on this Windows offline here that has everything I need on the package, and I can download that straight from java.com. Now that I've downloaded both files, I'll just install. I need to install Java first, so I'll click on that file, select yes, and then just move through the installation process. All right, now that Java is installed, I can proceed to ScadaBR installation, just clicking on that file that I just downloaded as well. And then continue through the setup process. And then it's gonna ask me where is Java Runtime 8 installed. I just installed it here. So I'll just click on Browse, go to Program Files, Java, and select JRE 1.8. That's the latest version that I just installed. Click on Next. Then it's asking me which port it wants to start the service at. By default, it's 8080. That should be fine. If you have OpenPLC runtime running as well, they're going to conflict here on the same port, but I don't have it running here, so that's fine. You can change that port to something else if you want. Just click on Next and wait until it finishes installing everything. All right, installation has finished. I can go here and check ScadaBR Service Manager to make sure that my ScadaBR is up and running. And apparently it's all good. Service status is started and it is running, and it should be running every time I boot my Windows system, right? So it should start on boot. Now to make sure that everything went out correctly, I'll just type localhost 8080. And if I get to this screen, it means that I have everything installed. To access ScadaBR, I just need to go to localhost 8080/ScadaBR. So just pay attention to how you write this, because this is case sensitive. If you write ScadaBR like this, it won't get there. Or if you write ScadaBR with no capital BR, you will also get an error. So it must be Scada with capital S and capital BR. If you type that, it's gonna lead you to ScadaBR login page, okay? And since you just installed this, the default login username and password is admin. Admin. Okay? So we can log into our interface here. Welcome to ScadaBR. All right, we just installed ScadaBR, free and open source for us to play with. And now we're gonna integrate this with OpenPLC that is already running on my ESP8266 board. Okay, I'll just close this information window here. I don't need that anymore. All right, so this is the main page for ScadaBR, right? Where you have your events, and right now I don't have anything listed here. It's blank, right? So I can navigate through the menu items here on the top to add new devices, new points, so that I can start doing something with my ScadaBR installation. So let's go to data sources. It looks like a hard disk icon here on the top. And when I click on that, it allows me to select from a list of different protocols, one of the protocols that I'm going to use to talk to my device. Okay, so since OpenPLC talks Modbus, I'm going to pick Modbus IP. And it's IP because I'm using TCP/IP to talk to my ESP board. Okay, once I select that protocol, I just click on this add icon, and it leads me to another window to set up my what is called the data source. So where ScadaBR will be connecting to read information. I'll just call it ESP8266 on OpenPLC, right? And here I have my update period. So how often I want to read data from this device. I'll just put 1 second. That's usually enough to keep a fairly real-time window and animation. All right, the other thing I'm going to change here is the transport type. By default, it's TCP. I'll select TCP with keep alive. The only difference is that if I select TCP, it's going to close the connection at every query. So every second, I'm going to open a connection, query for some information, and then close the connection, right? If I select with keep alive, that connection will be open forever between ScadaBR and my device. And then every second it's just gonna query the information that I want. It's much less work and overhead, so that's why I like this option. Finally, I need to put my host address here. For my ESP board, that's the IP address that I'm gonna use. And the port 502, that's the default Modbus TCP port. Now I can just test to make sure that I have all my settings correctly configured. I can test with any of the 4 different Modbus data types here. I'll just select coils, put 10 because I don't have 100 coils on my ESP, and just click on read data. Sure enough, it brings me a bunch of coils here. They are all false. I can test as well with holding registers, and the information here is in hexadecimal. 0A means 10 in decimal, so that's correct. My first register is holding 10, right? So everything is good. I can go ahead and save this data source here. All right, now that I saved my data source, I can start adding data points to my data source. So a data point is a single specific value you're reading from your device. The data source is obviously the source of that information, the device that you're connecting to. The data point is just that single information you're going to read. So you're not by default reading everything on the device. You must define what are the points, what are the information you need to read or write to that device. Okay, so to make that process easier, I'll just put this window side by side with my editor, right? And my editor has all the variables on my program here that I'm going to work with. Okay, so I have my counter enable, reset, and their locations. Okay, so let's add one data point here. Just click on this icon to add and give it a name. I'll put counter enable, just like my counter enable here on my program. And this one is a coil. right? And it's located at address 0. Okay, that's all good. I'll save this. And I'll add another one called counter reset. That's also a coil, but this one is located at address 1. Okay, you can see it here. It's at address 1. All right, I'll save that one as well. I will add another point and I'll call it counter. I don't need the counter Q. I'll just use counter max. That's the maximum value, if you remember, the maximum value that my counter can count up to. And this one is not a coil. This one is a holding register. So it holds an integer, right? I can see here it's a type integer. So because Modbus does not define types, I need to select here what is the data type here that I'm reading. So I'm reading a 2-byte signed integer. Okay, if I was using a float somewhere, well, a float will not fit on a QW location. Maybe I need to make another video about floats. But if I'm using a float or a real variable, right, that holds precision points inputs like 10.0, 10.2, for example, I would use here on ScadaBR a 4-byte float, for example, right? But that's not the case. I'm just using an integer, and in that case, it's just a 2-byte signed integer, okay? And that's at location 0. Let's save this and add my last data point here. That is going to be counter value. I want to know what is my current value for this counter. And that is also a holding register, 2-byte signed integer, but this one is at location 1. All right, save this. Okay, now I have all my points here, and all I have to do is to enable them. So to enable them, I need to go on the status column here and click on this icon for each one of the points. All right, and I also need to enable my data source. Otherwise, ScadaBR won't be connecting and reading data from my device. Okay, I click on that icon and now it's enabled. I can go back to my data sources window and I see here the status. It's enabled and working. Now that we have all our data into ScadaBR, we need to find a way to visualize that. That's the main point for an HMI, right? So let's move back this window to full width, and I'll go to the second option here in the top bar menu called graphical views. This section allows me to configure and create graphically the views that I want to display for my HMI, right? So all my data will be showed here on those views. So right now I don't have any views. I'll create my first one. So call it OpenPLC view. That's a good name. And one of the good things about this graphical views is that I can select a background image. I highly recommend you to do so because that will allow your view to be bigger and to display all the information. You can easily create that on like Photoshop or even Microsoft Paintbrush or something. But as long as you have a full width, a full screen background image, that will make it easier for you to place the components on the screen. So I already created one here on desktop called counter background, and I can now just select this file and upload it, and this is what I have. Okay, this is just a picture, and then I can add elements to this picture to make it animated, and that's what we're going to do next. So for the components here, I have a small drop-down list of items that I can add to my view, to my screen. The first thing I'm gonna add here is buttons to control the state of my counter, right? So I'll just select a button right here and I click on this button to add it to my view. So you see this little Lego block here in the middle of the screen. When you move your mouse over it, you have a couple options that allows you to change settings on this element that you just added. The first item here is to select the point you want this element to be connected to. Since we're using a button to control our counter, I'll just select those two points that are possible for us to control, the counter enable and counter reset. So this one will be associated with counter enable, and I just save this. And then I like to change a couple parameters on this button. So when the counter is true, I'll just display counter enabled. And when the counter is false, I'll display counter disabled. Then I have the option to control the height and width of this button. Let's play with a couple numbers here. How about 200 and 240? Maybe that will be good. That's too big. Let's put 100 for the height. All right, that's good enough. Then I can position my button on the screen anywhere I want. I like to use this feature here that's called Align Element, and I can click on Move with the keyboard arrows. Just select my item, and I press the left and right arrow keys to position it whatever I want. So I just place it here on this white square in the middle of the screen here under my counter settings. All right, that's good enough. And I can press ESC to get out of my screen alignment. Then I will add another button here doing the same thing, associating that with the counter reset, and then changing the name for, I can put counter running when it's true, or actually it's a reset when it's reset, when it's true, counter running when it's not true. So I'll just put 100 in my height, 240 in my width, so that it looks exactly the same as the other one. And I'll align it with the other one as well. All right. Okay, so looks good. I can get out of that window. So I'll just go ahead and save here. So this is what my screen looks like. I have two buttons that displays the current status of my counter. And right now it's disabled, but it's set to run. Okay, so I can enable it here, clicking on this button. It's now enabled. I can reset it here, and I can disable it again. All right, what else I can add here? Well, we need to show our counter somewhere. So there's another element that I can add. Let me go back to edit mode, and let me add another element to show my counter status. There are different elements that will associate with analogs or variables here. I will just pick this analog graphic. This is a good one. And on the analog graphic, the same thing. I just move my mouse over it, and I can select the point that I want this thing to be associated with. This one will be associated with counter value. That's my current count. And then I can select from a list of images here what graphical element, the representation of that variable. And the other thing also, I will select the range for that data that I'm going to display. So for now, I just have the minimum count is 0, the maximum is 10, and then I will just display the text here. That helps. And I will select an image set here. There are a bunch of images. Some of them are named in Portuguese. This is a good one. This is a big tank. And I'll just save this. And here is my tank image. And I can move it to the right window as well. Right? Put it right in the middle. Okay. Now I can save this and see my screen in action. All right, let's see this in full screen. I can click here for full screen and press F11 so that I have full screen on my browser. And this is the HMI. It's live. I can click on counter disabled here to enable it. And now I can see that it's counting up. If I allow it to run here, it was reset. There you go. You see the animation is going up on my tank. It's reading directly from the ESP board. All right, and I can reset it. Goes back to 0 and stays there. I can put it back to run. I can disable my counter and will stop whatever I clicked on the icon to stop and disable it. It can continue. So yeah, I have full control of my counter, just like what we did with the PyModBuzz example, but now we did it graphically using an HMI software, right? Now to get out of the full screen, I need to press Ctrl-Shift-F to get out of full screen, and F11 so that I get back to my browser view. And I can add one more thing to my HMI to make it perfect. I'll just go back to edit mode, and there is one element that is very useful and very customizable. That's called a server-side script. And I'll use this one to control the maximum value for my counter. Okay, I'll add that here. And then I'll associate this element with, I can associate with whatever point. It's very flexible, so both digital and analog values here are supported. So I'll just put here the counter max, okay, and save this. Now on, let me just move this over here, and let me change the script that I want to display on this element. There are a couple templates here that you can pick from. For this one, I will just use the slider because it's a nice one. And then it brings the script on this window here on the bottom. You can read the code here to understand exactly what it is doing. It's highly customizable. You can put a code here to, you know, change the fonts, to change the size of things, colors, but we'll just play with the elements here. They're simple for us to use. So the maximum value for this slider, I'll put 100, and for the show value variable, I'll put it as true because I want the element to be displaying the value, current value for it. So I'll just save this, and here I go. I have a slider. All right, and now I will save this view, go back to full screen, and I have a full HMI for my counter solution. So when I pick this slider here and slide it up, now I'm allowing my counter to count up to 66, right? So just by sliding the slider here, you see that it's already at 10, and it's going up 12, 14, and it's gonna count up indefinitely up to 66. I can also make it go back 16, and it has already reset. You see here, you can put it in like 4, so it will count up to 4 and reset, right? So I have full control of my program here through an HMI running on free and open source software, right? Hope you guys have enjoyed this solution. There are other HMI software, as I mentioned, that will work as well. But this gives you a lot of flexibility with open source software. All right, see you guys in the next video.